I think no one really expected that. There's a need for new theory.
You've said, this is probably the closest that we'll get to meeting an alien.
It's contact across a huge evolutionary divide.
This is Peter Godfrey-Smith, professor at the University of Sydney and the author of Other Minds, The Octopus, and the Deep Origins of Consciousness. The professor has a new speculative theory of rhythmic consciousness.
What we thought of as noise is not just noise, it's integral to consciousness.
My name is Curt Jaimungal. This is Theories of Everything, a channel where I interview researchers regarding their theories of reality with rigor and technical depth. Today, we explore what makes the conscious self. Are you, for instance, multiple selves? We also talk about the simulation hypothesis and why the octopus is one of the most bizarre creatures we've found on this planet, at least so far.
And there is an explanatory gap.
I'm going to read a quote of yours, Professor. This is probably the closest that we'll get to meeting an alien. Explain what you mean by that.
Well, that is a claim about octopuses and other cephalopods. So you've got octopuses, cuttlefish, and squid, who are a fairly closely related collection of animals that have, I think, a special status when you look over the whole of the animal kingdom. Because on the one hand, they have large nervous systems, very complex behavior. They are intelligent animals, and I think we have good reason to believe that they have experiences. I think, well, we know less about squid, but just going on the similarities between them and octopuses, I think we certainly have good reason to think that octopuses are probably conscious animals. And they are so far from us on the evolutionary tree, on the phylogenetic tree, the tree of common ancestry that links all animals on Earth, or everyone, all living things, you and an octopus, you and a fly, you and a leopard, but not just animals, you and an oak tree, you and a bacterium are linked by connections of common ancestry. If we go back far enough in time, we get to an organism who's an ancestor of both you and that octopus and leopard and fly and oak tree and so on. It's just a question of how far we have to go back. And in the case of animals, most of the animals that we think of as intelligent and sensitive and probably conscious and so on are reasonably close to us in evolutionary terms. But cephalopods, including the octopuses, are miles away. To get to a common ancestor of you and an octopus, we have to go back to quite early, not in the history of life, but in the history of animal life. We have to go back, no one really knows exactly how much. In the book Other Minds, I said about 600 million years. Something like 570 might be a figure that would be given now. It's not very different. And that's very old. That's very early in the history of animals. So when you meet an octopus or a cuttlefish, you're meeting an animal that has a really enormous evolutionary separation from yourself, but there is this encounter, this sense of contact. One has the sense that there's a lot going on inside. They're sometimes interested in us, in something like, it seems, the same way that we're interested in them. It's contact across a huge evolutionary divide. That's the idea.
Can you please disentangle these terms that ordinarily get bundled together? So mind, a conscious mind, brain, and even intelligence. Like, can you have one without the other? And how does that go? What does that nesting look like, or that partial overlap?
Right. I think the first thing to say is that everybody who talks about this is doing a little bit of stipulation, and they're guessing on certain things. They're making empirical guesses. There's different ways to set this up terminologically, but here's the way that I would set it up. I think that mind is a very, very broad category. It's a broad concept that encompasses some intelligence-related properties and some consciousness-related or experience-related properties. And those two are somewhat distinct. I think that you can have genuinely intelligent systems that probably have no feeling, that are probably non-conscious. And I think the flip side is tricky, but there can certainly be evidence for a form of experience in organisms, in animals that don't have a ton of intelligence. I mean, to some extent, these really are separable. So mind, I think of as a kind of broad category, and there's a cluster of intelligence-related features and a cluster of experience-related features. And that's the first set of distinctions I would make.
Would a mind always have to have a conscious component in order for you to consider it a mind? Or can there be a purely unconscious mind and then you would still say, well, this animal, even though it never had the ability to even develop consciousness, let's assume some animals don't, maybe a large assumption, but whatever. Would you call that a mind at that point?
I do think this is partly a stipulative matter. I mean, there are some people, I think Susan Schneider's an example, who just says, no, I'm not going to use the word mind for something that has no scrap of consciousness. I think she thinks that's just integral to our notion of mind. And there are probably a number of other people who would say the opposite, who would say that consciousness is a kind of a special, refined feature of some minds, and you can have a lot of mentality that is unconscious mentality. I would probably say something closer to that second thing. I don't think there's an unavoidable connection between mentality and consciousness. Let me say a bit about what I think a mind is. And, we're all grasping and feeling around here. So I don't say any of this in a way that's too definite. But let's think about two collections of properties. First is a kind of selfhood. I think that mentality goes with a kind of selfhood. There's a sort of selfhood-related component to having a mind. But that's not everything, because bacteria, I think, have a pretty decent selfhood. They are self-maintaining, in a sense, almost self-defining organisms. I think the notion of self-preservation, self-maintenance is very closely tied to the idea of life, and it's part of what's involved in mentality. But I don't think that bacteria... I think we might talk about exactly how I would set this up in a moment, but as a rough way of talking, if someone asked me, do bacteria have minds? I say no. What do they lack? They've got the selfhood. There's a kind of information processing requirement or component as well. There's just not enough perception, cognition, that cluster of things going on inside a bacterium. So let's say there's a sort of cognitive side that involves information processing, perception, memory, action selection, and so on. And there's a selfhood-related side. There are systems that we're familiar with that have tons of the information processing side with not very well-defined selfhood. And what I have in mind there is ordinary collections, like a sports team or a club or a band or an economic entity like a company. There's lots going on in terms of information processing, but the selfhood doesn't really live there. It lives in the more in the individual people who make up that social object. So we're familiar with cases where there's a lot of information processing of roughly the right kind, but a sort of low level of selfhood. And we're familiar with cases that have a pretty good selfhood, but not much information processing going on inside. And single-celled organisms, I think, are a good example of that. You have the two together, you have something with a mind, roughly speaking. I think mentality lives in the kind of intersection of selfhood and information processing or cognition. Computers lack selfhood. They may also lack some of the important information processing features to have a mind. Plants, they have a sort of low level of both. They have decent selfhood, but a plant like an oak tree is in some ways a bit more like a collective or a social entity than a single well-defined organism. And they have quite a bit of signaling and information processing going on in there, but of a kind that inherit some of this low selfhood character.
When someone hears the word selfhood, they may think in terms of some self-conception, some identity, but you also ascribe selfhood to bacterium, which we ordinarily don't think of as having thoughts of this is who I am and I'm going to go in this direction. It just does what it does, almost like a computer. But a computer doesn't have selfhood.
Right.
So what is selfhood? Is it more defined by the causal structure? When kids are playing hot potato, they throw some potato to someone else. Imagine they process the potato. Each person processes the potato. Then they throw it. And that little circle constitutes one selfhood. And then another group is playing hot potato constitutes one selfhood. Like, what is it?
Well, selfhood is the attribute, of being a self. So if you have that collection of kids playing hot potato, that's a social group and made up of individual human organisms. And I think that a human organism has a ton of selfhood. They're a good self. They're a relatively well-defined self. Our boundaries are reasonably clear. You can count us. We engage in self-preservation much of the time, both consciously and unconsciously. We make our way through the world as an enduring and reasonably well-bounded unit that looks after its continuation. And a bacterium, in a much simpler way, has some of the same features. It makes its way through the world in a way that maintains its, in some ways very improbable, very difficult to maintain organization in the face of tendencies for order to dissipate and so on. Now, the collection of kids playing hot potato, they come together, they form a unit, and there is something that unifies them. They are a kind of object, and you could talk about disturbing this thing. If you threw something into the middle of the group, they would react, and in a sense, the collective would have a collective reaction. But this is a very, very minimal case because the kids could stop at any moment, go off and do something else. They could be on their own or they could join a different social group. There's a kind of faint element of selfhood that the spontaneous game possesses, but, we're talking about something with a very minimal level. I think a bacterium has more. An animal has a lot more. I think selfhood is a sort of thing that comes in degrees, and the sort of the kinds of things you're talking about when you talk about the way they perceive each other and act in a way that's highly coordinated, those are in the ballpark. Those are the right kinds of things to be leaning on here, I think, but it's a low-level case.
I want this podcast to talk about what a mind is and what is a unified mind and how many minds are in an octopus. And we're going to get to all that in case people are listening and wondering where this is going. But you also said, when I asked about what is a mind, and you said there's somehow stipulation here. And I'm curious about when philosophers are talking about some concept like mind, what is it that they're arguing about? Why can't we just put out a stipulative definition of mind and just say, okay, we're going to agree that this is what mind is? Why is there disagreement? So for instance, in math, you say integration by parts means this. A Lie group means this. Supersymmetry means this. And there's no one that's saying, yeah, but I think a Lie group means this and that. So is mind just such a loaded word and it comes with us with prior baggage and we have properties that we want mind to have, and so philosophers disagree whether your definition satisfies those properties, or is it that the implications of what a definition of mind would have implications to ethics, and so we may disagree with what it entails for our morality, or like what's going on exactly?
Definitely those things. The feature you talked about there where the idea of a mind comes with all sorts of historical baggage. It links to ethical ideas, to religious ideas, to everyday ideas. There's a lot of historical baggage there, and some people are going to want to insist that, if you have a mind, you're conscious, or if you have a mind, there's a kind of responsibility perhaps you have, and so on. But other people with a more scientific point of view might say, well, no, these are unwanted connotations. We should work with the concept a bit differently. And that will be a kind of stipulative move. I listened to a bunch of the episodes you did with Wayne Meyerwald, and one of the things he said right off the bat is people think entropy is one thing. It's not one thing. There's a bunch of different concepts that have an entropy-like characteristic, and in different contexts, different ones of those become salient. So the kind of beholdenness that a concept has to several different sets of interests and traditions and forms of investigation, that feature that we see in the case of mind, I think, is not that unusual. In a moment, I'm just putting a sort of bookmark here. In a moment, I would like to do a somewhat extended treatment of a comparison between mind and life in this respect. So in a second, I think that would be helpful.
Great.
But before I get to that, so there's a cluster of things that people have historically had in mind when they want to talk about the mind, mentality.
Okay.
And that's a reason why people are not going to agree. They're going to say, no, we want the concept to do this thing for us. And someone else will say, we want the concept to do something else. There's also another feature, which I'd like to emphasize here, which is more peculiar to my own approach to these things, which is the absence of a cutoff between having a mind and not having a mind. I think though the language we have very much suggests that there's a sharp, at least a reasonably sharp yes or no divide there, I think the scientific concept that we will wind up using some years from now, a sort of descendant concept of our current messed up informal network of concepts, is very likely to have a gradient or graded character, a more versus less character, rather than a yes versus no character. So if someone wants to say, do earthworms have a mind? I think 50 years from now, I can imagine a good answer being, well, they have a lot of this aspect of mentality or mindedness and hardly any of this other aspect. And that's just how they are. That's kind of fine. That's something we should just get used to. The idea of a yes or no distinction here is unfortunate. Will I do the life comparison now, or do you want...
We'll get back to that.
Okay,
I wrote it down as a note. If you drink, you've been told that you feel less than 100% the next morning because alcohol dehydrates you. Cheers Health says that's only 10 to 20% of it. The rest happens while you sleep. Your brain compensates for alcohol by turning down its own calming system. So you're in rebound once the alcohol clears. Your liver turns ethanol into acetaldehyde, which is more toxic than alcohol itself. Then it turns it into harmless acetate. The second step is that bottleneck. And while acetaldehyde is around, that's what you're feeling. Cheers Restore is an after-alcohol aid that you take after your last drink or before bed. It uses DHM, a flavonoid, from the Japanese raisin tree that interacts with the GABA receptors and L-cysteine, an amino acid that binds to acetaldehyde. The formula is patented, no proprietary blends. Cheers says that you'll feel at least 50% better or your money back. Go to cheershealth.com/TOE and use the code TOE, T-O-E, for 20% off your entire order. That's Cheers, CHEERS, health.com/TOE. This video is sponsored by Cheers. So, something just happened recently. The Economist sat down with Elon Musk, who told him that AI will surpass human intelligence within 5 years, and then in 10, humans won't be running the world. It went viral, and I recommend you check it out. See, The Economist is more than a magazine. Actually, I subscribe to The Economist's annual subscription. Their science and AI coverage is among the best that I've found anywhere, and I say that as someone who reads plenty of it. They even covered how dark energy may be weakening with time. If that holds up, it completely changes our understanding of the universe's fate. Those are exactly the kinds of questions that we explore every week on this channel. Now, The Economist is, of course, known for global affairs, both political and economic reporting. Interestingly and flatteringly, TOE is one of the only podcasts that The Economist partners with. So, as a TOE listener, you get their summer sale, 50% off the annual subscription, but only until August 17th, 2026. That's not a deal they have just anywhere. Head to economist.com/TOE, T-O-E, to subscribe. That's economist.com/TOE for 50% off the annual subscription. If mind is going to be graded, and this is something I brought up to the late Anand Vaidya, who you may also know. You mentioned Susan Schneider, and Susan Schneider's a friend of this channel and mine who had this conference called Mindfest. We'll place links on screen. Anand gave one of the first talks there. And Anand was saying consciousness may be somehow graded, that everything has consciousness, it's just different degrees. But then I said to him, yeah, but if it's just different degrees, unless you're going to say that it never hits zero, you could just define consciousness as if it's zero or non-zero. Like we define something as a charged particle if it has a non-zero charge, even though it's extremely, extremely tiny.
Right.
Then if that's the case with mind, do you imagine that everything has mind? Every single little thing has some degree of mind? Or do you imagine that there are some objects that have zero mind? And if that's the case, then what the heck is that flip between zero to that minimal amount?
Right. This is, I think, exactly the thing to think about next. I think there are definitely, well, not definitely, I think there are very, very probably lots of objects that are zero, that have no mind at all. I think most of the things around me right now just don't have any little element of mindedness. So whereas an earthworm has a little bit, and a bacterium probably, it's kind of in the ballpark. So how do we handle the divide between a tiny but real amount and a genuine zero? And I think the right answer to that is to say that the concepts we're using when we ask that question, we're taking it that there's this definite thing, mindedness, or having a mind, or mentality. That's a definite thing, and if one has a graded treatment of it, one then has to address exactly the question you ask, which is, are there zero cases, or does everything have a non-zero degree, and so on? That, I think, will have to go, will probably go. I think that is not a likely feature of our descendant vocabulary. Maybe now would be a good time to talk about life. So let's, and this
Please.
I think would be worth I think the analogy between life and mind, as they've been scientifically handled in, especially in recent history, is quite helpful here. Okay, life. What happened to the idea of life? What happened to the idea of life in biology? Is it still a mystery? Is it solved? If it's solved, what is life? I think the right answer to that question is that biology has partly explained and partly deflated the concept of life. The idea that there was a definite thing, being alive, being a case of life, where we could ask these questions such as, does everything have a little bit of life? What's the nature of the divide between a little bit and none, and so on? That way of approaching the topic has been sort of gently deflated, I think, in a particular way. If you look at an ordinary high school, even biology textbook now, they're not going to give you a very unified treatment of what life is. They'll give you a list. There's a bunch of properties that are characteristic of living organisms. And here, the next move I'm going to make is my own preferred way of handling this, but I think it is a kind of center of gravity in many other discussions. Involved in life, there's a cluster of features that are, roughly speaking, metabolic, that involve, using sources of energy to maintain an otherwise improbable form of organization in the face of tendencies for order to dissipate and so on. There's a kind of self-preserving, self-maintaining, raw material using metabolic cluster of properties. And there's a cluster of properties associated with reproduction and evolution, entering into the evolutionary process, being able to make more things like yourself, and so on. So there's these two clusters. And in the case of each of those two properties, if we don't use the word life, if we just talk about those properties in their own terms, we can talk about how they grade off into nothing. You can talk about different kinds of chemical systems and how some of them have a tiny little bit of a self-preserving or self-maintaining character, but it can be so fragile that it doesn't really count. And you can have autocatalytic networks of chemicals. And you can have things like protocells that really do kind of maintain some order for a time. We don't ask where life begins and ends. We just talk about the advent of self-maintaining patterns of chemical organization. And then on the reproduction-related side, we have very, very minimal cases which are completely explicable, such as prions would be a very, very minimal case, a sort of self-propagating abnormal form of protein folding that causes diseases in animals and in humans. It has a kind of contagious quality, but it's a situation where an abnormal folding of some protein, when it comes into contact with other proteins of the relevant kind, it can induce the same abnormal pattern of folding, and that causes all sorts of problems. So that's a very, very faint case on the kind of reproduction-related side, replication-related side. Now, suppose someone comes along and says, okay, fine, but I want you to answer the question of which of those things really matters to life. For example, viruses. Viruses have tons of the kind of evolutionary replication-related side, but they have no metabolism at all. They are complete metabolic parasites. They have to use the metabolism of a cell they're infecting. So they have lots of this and none of that. Is a virus alive? I think the right response to that question is, it's not a good question. They have some of this, they don't have that. The two together are the kind of content of our notion of life, but the way that our notion has developed is a way such that you shouldn't ask about cases like that, are they in or they're out? They're neither in nor out. They are what they are. Viruses, viroids, some of the very simple systems that people imagine in origin of life scenarios that have a little tiny bit of the metabolic side, but none of the reproduction side. Are they in or out? They are what they are. The concept is best used without asking the question that way. So that's the life case. I think the mind case will follow a similar path. That's a prediction, but I think that's a likely way that these things will get resolved. So then when someone says, does an earthworm have a mind? The answer will be, well, it's got some of this set of mentality-related features. Selfhood, I would say. They've got pretty good selfhood, but their information processing capacity is very limited. They do have a nervous system. Do they have a mind? Not a good question. We should move. I see us as moving past that question in the future, in the case of the mind, in the way that we already have, I think, for many people, not everyone, but I think in general we have moved past that question for the case of life.
What do you mean when you say deflated?
If you go back, suppose you go back a bit over 100 years to early 20th century, or actually late 19th century is better, life looked like a special thing. Vitalism was a theory. It was the idea that there is a kind of distinctive property that living things have that we have to understand, and it might have a physical basis, but it might not have a physical basis. It's a thing that calls for a special kind of focused explanation. I think that life, it's not that we have taken that question and answered it, it's more that we've taken that question and seen how the development of an answer means you shouldn't ask questions of that sort of highly focused kind that people used to ask. And again, the case of viruses is if someone really cares about whether viruses are alive, I think they have not appreciated the sort of mild deflation that the concept of life has had.
So we think of our mind as being quite special, but there's something extremely special about the octopus. So what is it? Why are you studying octopuses? What's going on with octopus? Or what is it? Octopi. What is going on with octopuses?
Octopuses, yeah. Well, you could do octopodes and really exhibit classical learning, but octopuses I think is fine. It's that feature that we talked about a little while ago, that combination of complexity in behavior and nervous system and evolutionary distance from us. They're so far from us. They have this quasi-alien quality. And because of that distance, suppose we list a bunch of similarities between us and an octopus. We have a camera eye. An octopus has a camera eye. We can navigate pretty well, find our way home. Octopuses can navigate pretty well. We can learn by reinforcement. We have a kind of attentiveness. We can track whether other animals are paying attention to us or not paying attention to us. All of those things would have had to have evolved independently on the two lines, the line leading to us and the line leading to octopus. The common ancestor, if we think about the common ancestor of you and an octopus, probably a little kind of flatworm-looking thing, maybe a centimeter long, maybe less than that, had a nervous system for sure, lived in the sea for sure, so it could probably, move around, and it was an animal. It had a sort of animal life, but very simple, probably, in its behavioral capacities. The whole idea of, finding your way home, and very, very simple animals can do that. But the kind of learning from experience, the attentiveness, having a camera eye, being able to sort of see objects in the world, all of those things would have had to have arisen independently. So there's this wonderful set of questions we can ask about the similarities at the tips of the tree, our branch and the octopus's branch. Dreaming is another amazing one. I mean, that's right at the moment. I think that's becoming very interesting. We don't know that octopuses dream. It's very hard to study dreaming in non-human animals of any kind, but the evidence is not bad, and that has to do with the fact that's very lucky for us that the skin, the color changes, the pattern changes that octopuses and cuttlefish can do, they're a kind of window into the brain. And when the animal's asleep, you can see some aspects of what's happening in its brain by looking at the continuation of color and pattern changes on its skin. Now, when I've had conversations like this, roundabout now, I would say I very, very much doubt that the common ancestor of you and an octopus had sleep or dreams. I'm not so sure now because sleep is turning out to be very common, and it might be that a faint analog of dreaming is common as well all over the place. But you can see the general picture, the idea that there's this deep evolutionary divergence, lots of complexity in us are kind of meeting. That's why they're so exciting to me.
Actually, Michael Walker, if I'm not mistaken, he's a sleep scientist. He's not an evolutionary biologist, but he has a speculative theory that sleep is the default state evolutionarily, and that wakefulness is what evolved.
Yeah, there's a few people who say that. Rodolfo Linhas, a neuroscientist at NYU, who I admire very much. He's a very sort of hard-headed neuroscientist, but he has some very adventurous ideas. He says stuff like that. And Yuri Bashaki, another neuroscientist whose work I read pretty closely, similar idea. And I don't understand what they mean by it, really. And I don't understand, perhaps you could tell me what this guy thinks. I mean, if you're an animal, you have to spend a lot of your time doing stuff. You've got to deal with the world, and nervous systems evolved to enable animals to deal with choice of action, perceiving what's happening, working out what to do in response. You can't just sit there and photosynthesize if you're an animal. So the idea that sleep comes first, I've not seen anyone claim that organisms without a nervous system can sleep or dream. I'm being a bit cautious here because I know that there's some work on the effects of general anesthetics on organisms like paramecia, on single-celled organisms that are more complex than bacteria. I think people believe that paramecia have a sort of interestingly similar response to general anesthetics to an animal's response. So, but bracketing that, I think of sleep as a feature of nervous system, brain and nervous system activity. There's some evidence for sleep in some jellyfish, so which don't have a brain, so nervous system rather than brain. And once you have sleep, active sleep is very common. The sort of what in humans is REM, or rapid eye movement sleep.
Yes.
It has analogues in flies and bees and octopuses and all sorts of animals. And as a sort of a rough thing, one might say that active sleep might naturally bring with it something like a dream state. Now, that's oversimplifying because we have dreams outside of active sleep. We have non-REM sleep dreams as well. It's not so simple, but there does seem to be a close connection between REM sleep and dreaming. And right, if that's fact one, then fact two is that active sleep is in many, many animals. And there might be some analog of dreaming, hence, in a lot of animals.
The way that most people think of the mind, the brain, for us is more like a CPU, and then there are other smaller processes that are occurring throughout the body. Your heart has a rhythm, your legs move, and so forth. But an octopus is different in that it has a huge cluster along each of its legs, each of its arms.
Yeah.
And then it also has something that's toroidally, it's not a brain like ours, it's almost like a donut, if I'm not mistaken. And
Yeah.
if it eats something sharp, it could actually hurt itself in its brain.
Yeah, right. Its esophagus goes through, the brain surrounds the esophagus, so you don't want to get a piece of bone stuck in your throat if you're an octopus.
Okay, so what is the significance of this when it comes to how many minds are in an octopus?
Okay, right. Well, let's work through it a bit. The octopus, right, the brain looks nothing like our brain. You could think of it as a kind of donut with these two big things attached to the sides, which are behind each eye. There's the donut, there's these things called the optic lobes behind each eye. And there are some other sort of clusters. There's a thing called the vertical lobe, which is an unpaired structure at the top. Well, in diagrams at the top, I guess, don't know if it really counts as the top of the brain, which is thought to be responsible for various more abstract and sophisticated elements of their cognition. And that is a brain. I mean, it looks nothing like a human brain. There's no cortex, there's no cerebellum, there's all the sort of familiar parts of a human brain don't have well-defined analogues even in the octopus brain, but it is a central brain. It's a central, it's a kind of limited CEO type controller. And then you have the peripheral nervous system where something like 2/3 of the neurons are found. And as you say, it's in the kind of upper arms and through the arms. And some people writing about that describe that as a kind of second system because the horizontal connections between those parts are quite strong. And other people describe it as a kind of 1+8 situation where there's a central brain and there's 8 of these peripheral systems. And this might be a case where, you could say it's not clear there's a right answer to which of those things you should say, but it's a big deal that more than half of the processing power is not in the central brain.
I should tell you, I read your book several years ago. Why? Because I had an experience of, let's just call it an excursion with elixirs, where I felt this oneness with everything, this as if I was pure consciousness or something like that. And that what we are as people are somehow tendrils of consciousness. And I searched around because I wanted to know, okay, I called it the octopus mind. That was the visual that I had for this. Like one root mind and the tributaries are these individuals, which we have the ability to traverse upward back into this unified head. And that the closest metaphor I could come up with was an octopus. And your book came up. And then I was thinking, oh man, okay, someone's explored this. And then it was about octopuses.
Right.
But your book hooked me despite me being interested in something else. So it's like I went to a store for cheesecake and then they served me pulled pork. But I kept eating your pulled pork better be damn good. If I went in wanting cheesecake, I should have said grilled octopus.
No, you should not have said grilled or pulled pork, actually. But cheesecake.
That's another discussion.
Yeah.
Yes.
So in this vision that you had we individual humans were like the peripheral parts of an octopus. We were like individual arms, and there was a central mind as well. Okay, why don't we think about that for a second? Why, right, in the case of an octopus, there's selfhood at the level of the whole animal. There's a kind of selfhood there. They've got two eyes and they act as a whole. But there's also this, it seems, this partial autonomy on the part of some of their components. And there are kind of evolutionary reasons why the integration is present, why there's a unified animal self there. And there are evolutionary reasons why this body has wound up with this very distributed control system. Now, I realize it's sort of applying a very heavy-handed scientific instrument to your vision, but I think it's worth doing. I mean, if we want to recognize the existence of minds, of mentality of various kinds, there ought to be a reason how they come to exist. There's got to be a kind of historical process or some kind of process that makes sense, that brings into being a mind with this shape rather than this other shape, or these features rather than these others. And what kind of story can be told about the transhuman, trans-species central consciousness that you were glimpsing? Is there something that can be said about why such a thing should be there?
There are some idealistic theories, I'm sure you know, in the philosophy of mind, which suggest or state that we're all somehow eddies in some other large unified field of consciousness, and that was an experience.
Okay, I guess I was using the case as a way to motivate the kind of attention to selfhood and the creation of selves of different kinds that I think of as important in understanding the nature of the mind. And if you understand how different kind of selves come to exist, I think you're making some progress towards understanding the nature of and the distribution of minds in the world. Now, if someone says for general physical reasons, and as you say, there are people who say this, that there's a kind of a total field in the universe that has self-organizing characteristics, right, I would then want the next steps as to why it should have a kind of self-related set of properties as well as just being a big thing that's there.
Okay, so a knotted thread for us to disembroil is experience, mind, and subject. In the case of an octopus, is it that there are multiple subjects, yet one mind, or multiple experiences, yet one subject, or what? Help me understand this.
Well, no one knows. I mean, right, it's both an intrinsically hard thing to study and understand, even if people were working hard on it. And not that many people, I think, are working hard on this. So it's a real area of mystery. I'll give you my guess. My guess is that there is a central subject in the octopus. I mean, the octopus can pull itself together and do things as a whole. It can do quite complicated things as a sort of integrated, cohesive unit that senses and acts and all that kind of thing. And it's also true that when you watch an octopus just hanging out in the sea, when it's relaxed, it's not doing anything much, perhaps it's just sort of wandering around, or perhaps it's even sitting still, the arms have this tendency to individually explore in a way that looks autonomous. And we do know that there's quite a bit of processing power inside each of those arms. It looks a bit autonomous and there's processing power there. So one combination of views that I think is coherent is that there's a central, definite octopus self, but it allows a partial, it sort of can relax its central subjectivity when there's reason to do so. And the arms have so much processing power that they have what? Do they have a mind of their own? I think no, they don't have enough selfhood. They don't have enough of that kind of distinctness and autonomy to count as having that. but they're the kind of case that probably our vocabulary, which I think of as pretty primitive at the moment, doesn't really get much of a grip on. So when I said earlier in that discussion of life that we've taken this, in retrospect, rather crude concept of life and broken it down into sort of much better understood components, we haven't done that with the mind yet. And I think that when we've done that with the mind, we'll have a language for the octopus arms, that they have, they can have in some circumstances some degree of autonomy, perhaps. And I doubt that they had their own experiences. I think that's probably going too far. I wouldn't rule it out. I don't think we know enough to rule it out.
Now, why is this even a question that we're having? Why is there some controversy to this question? Because for us, suppose you go on a bike ride or I go on a bike, whatever, the listener is going on a bike ride, their arms and legs are moving and doing relatively intelligent acts on their own. In fact, if you attend to it, you then start to lose your balance a bit because you're now paying a bit too much attention to your arms and your legs. They have to be going off. And even for myself, sometimes I think of an entire sentence. Suppose I say Peter Godfrey-Smith is a believer in conformal gravity. Whatever, if you're not, you may be, I don't know, whatever. Let's just say that. I think that thought as almost one bit because I've compressed that down, and I tell my arm to write it. I look away and I say, yes, babe, I'll be there in a second. Something completely different with my conscious mind. I look down and I finish the sentence.
Yeah, but it's still your brain. It might not be your conscious, the conscious side of your brain doing it, but it's not literally the arm on its own. My understanding is anything that sophisticated is definitely brain directed, even though you don't know it, even though you aren't paying attention, even though you're in some sense unconscious of it. And we might come back to that. I mean, the idea of a divide between the things you're conscious of and the things you're not conscious of, that's another divide that I would put some pressure on. Maybe we could come back to that if that's okay.
Yeah.
But in the octopus case, it really is just the arm for some of this stuff. And in gruesome experiments, if you chop an arm off, it can still explore a little bit. It can still sort of probe and sense, and it has a little bit of genuine capacity on its own.
Whereas if you chop my arm off, it wouldn't get past Peter.
Right, and it wouldn't ride the bike.
Okay, got it. Yeah. Great. Yeah, I mean that would be interesting if it did ride the bike. I mean that would be evidence.
It would be quite a big thing. Yeah.
So, what is the pressure that you want to put on the divide between conscious and unconscious?
Yeah, sure. This is partly perhaps my own idiosyncratic take on some things. Here is an example that philosophers often write about in this context when they're talking about the distinction between stuff you're conscious of and stuff going on in your brain that you're not conscious of. It's a famous example. David Armstrong, the Australian philosopher, way back in many decades ago, I guess in the late 60s, I think, early 70s, he said, imagine you're on a long distance drive. You're driving along. You can cover a great distance engaging competently in basic navigation and keeping the car on the road and passing other cars with no real conscious awareness of what you're doing. You might be listening to the radio, you might be thinking about your plans for the next day, and then you can suddenly come to 100 miles later and think, oh my God, I've driven all the way to wherever, to Toronto. And right, how should we describe that? Now, Armstrong, who introduced this thought experiment, he didn't quite want to say that when your mind's on the radio, the sort of navigational side, the vision of the road and that kind of thing is completely out of experience. He didn't quite say it like that, but many people now do say it like that. They want to say that your conscious mind will be focused on essentially one or perhaps one or two things at a moment. You can switch quickly, but it's really one at a time. And if you are attending to the radio, then the side of the road is just not in your conscious experience at all. People say that. Lots of philosophers say that, and lots of psychologists. Stan DeHaan, who's one of the sort of neuroscience / psychologists who I most admire in this area, He says that, and he reiterated it last week, actually, in the commentary he wrote on the AI global workspace phenomenon. When the Anthropic people found what they called a workspace inside Claude or I guess it was just regular Claude.
That's right. Yep.
Yeah.
The J space. Yep.
Yeah, the J space. And Dehane wrote a commentary on this because the workspace idea is in part his idea. It wasn't solely his idea. Bernard Baars introduced it, and Dehane worked with people, with Nakachi and others. But Dehane is the sort of flag waver in some ways now. And Dehane reiterated in his commentary on that AI paper that the conscious workspace for a human being has one thing in it at each moment, one thing. And you can switch quickly, but it's really just one. Now, every time I read that stuff in Dehane and others, I think, my God, my experience really seems to be very different from yours. And an alternative view, the view I would offer as at least on the face of it, natural description, is that at any moment, experience for an ordinary human is very multifaceted. There's something you're attending to. So right now I'm attending to the screen and the computer, and there's this bright light there. But, there's a temperature that is not wholly out of my awareness. If it was a bit warmer, I would feel different. I'm sitting on a hard chair rather than a soft chair, and I think that makes some contribution to what it feels like to be me right now. It's been a certain number of hours since I ate anything. I'm not particularly hungry, but I'm, a little bit perhaps. Now, in my way of thinking of everyday experience, at each moment, a person has what I would call an experiential profile. That's just my terminology, my jargon.
Sure.
And the profile has not so much elements in the sense of building blocks, but it has facets. There's the kind of sensory attentive facet. Right now I'm attending to the screen, but there's mood, energy level, temperature, your sense of where your body is. I think, those are real. The first three of those, I think, are really good examples to use: mood, temperature, energy level. All contributing to what it feels like to be me or what it feels like to be you. Now, this, I think it's important to emphasize. If this sounds natural to me and to you, it's very much not what a lot of people say. A lot of people say, no, that's got to be an illusion. You've got to be switching quickly between your mood and the screen and the hardness of the chair and so on. It really is one thing at a time.
Mm-hmm.
Now, continuing on with that train of thought, I think that once you take seriously the idea of an experiential profile, a sort of a whole that's characteristic, whole with a W, wholeness as characteristic of experience, there's probably lots of things that make tiny contributions to your experiential profile. So when you were writing something, but your attention was taken by something else, and you were having a conversation, and you sort of finished doing the writing. I don't know. I mean, some people would say, "Oh yeah, that was outside of consciousness altogether." I would be tempted to say, well, not really, probably 100% outside. It's probably making a small contribution. Now, how do we test the difference between wholly outside and a small contribution? That's really hard. I mean, I accept that that's very hard. And this is a situation where, as a philosopher, I'm somewhat unashamedly willing to say it'd be really hard to empirically test that distinction, but nonetheless, I think this is an important distinction to think about.
I'm on board with what you're saying. I always find it quite odd when someone says that you're only able to focus on one bit at a time. I mean, what is one bit? So for instance, we can get in the nitty-gritty here about what co-conscious means and the distinction between your experiential, what did you call it? Experiential
profile. That's the unit that I like.
Profile versus a phenomenal field. Right. What's the difference between that and a phenomenal field? We'll get to that. But suppose I'm looking at a kettle right now and I see that it's brown and black. Are those separate bits? And then are these all then fused together into one bit? You could fuse anything together into one bit. Even earlier when I was saying Peter Godfrey-Smith believes in conformal gravity, I said that was one bit, but is that two?
Right.
I don't know how to measure that. And it doesn't feel to me like it's one bit.
I think there's a sufficient condition for it not being one, which is that it involved more than one modality. And experiential profiles for me involve more than one modality. There's the stuff that you're seeing, hearing, and feeling. I think once you're combining modalities, you can't say it's one thing. People who write about this topic in consciousness science, they sometimes talk about gist consciousness, the idea of the visual gist of a scene. So if I'm looking at the screen, they will say, well, the whole screen with its colors and its shape and its movement can sort of function as one thing, not literally one bit in the measurement sense, but one component, one item or something like that. The gist can be a thing, they will say. And to that, I reply, okay, fine. With vision, maybe. But once we have vision and an auditory stream and a kind of sense of temperature and your mood and things like that, once there's a ton of modalities in there, it's not just one thing. There's no way to describe that as a single thing.
Curt here. Note that if you'd rather listen to Toe, we're on Spotify, iTunes, everywhere with a podcast catcher. You can just search my name or Theories of Everything. And also, remember to hit subscribe. So, did Anthropic find consciousness in Claude? What did Dehane actually say?
He was being pretty measured. The Anthropic researchers were also pretty measured. They said, look, this is interesting. Spontaneously, without being told to, Claude has generated a structure in its processing that has some features in common with what people like Dehane refer to as a global workspace, where a workspace is a kind of, well, actually, this is tricky. When you say workspace, it sounds like it's a place in the brain where stuff is being integrated. A small amount of stuff is being attended to and integrated with other important aspects of what's going on. It sounds like a place. And I think pretty much everybody thinks that's a misleading. You shouldn't spatialize the workspace. And Bernard Baars, way back when he began writing about the workspace concept, he used the metaphor of broadcast. Some bits of information are broadcast, and that's in a way the opposite of a workspace. If it's being sort of sent to the whole, it's not being brought into a single place. So there are different metaphors, and a workspace, which shouldn't really be spatialized.
Well, he did call it a global workspace.
Yeah, right. Actually, global workspace sounds almost like a contradiction. If it's a workspace, it's just one little part. Right, it is called a global workspace.
It's a local, non-local.
It's a local, non-local workspace. And the Anthropic guys said there's something in the system that has some features in common with a workspace. And Dehane in his commentary said, yes, it does have some features in common. It also has differences. It's different from the human phenomenon in a number of ways. And Dehane wasn't saying we should believe in Claude being conscious. He was saying, look, yeah, this is not a small thing. This is interesting. It's surprising that spontaneously the computer system made for itself a somewhat workspace-like structure.
Now, is it that surprising, given that it's trained on language and our language? Presumably, our language would encode in it our cognitive structures because we're producing it with that. So is it that surprising that many of our own cognitive features, many that we're unaware of, are also going to be found there? And furthermore, we were looking for the Anthropic team already knew about global workspace theory. And so they're looking for something. I imagine there are various features that they looked for that they didn't find, and it's not as if they published about those. And I imagine that there are other features that are wholly alien to us.
Yeah, those questions about whether it's surprising or not are not ones I feel I don't know enough about the systems to answer. In the case of AI, I'm one of those people who's had to sort of go from 0 to 60, or at least 0 to 40, very quickly, because for a long while the LLMs have been a disaster for my university life. I mean, I'm one of the people. I'm a very traditional professor. I teach traditionally. I like students to write essays. That whole side of university life has just been instantly disrupted by the LLMs, and I'm quite unhappy about it. I must say, very unhappy about it. And partly for that reason, I just didn't want to pay too much attention to them. But now I think we have to pay attention. We have to pay a lot of attention. People like me have to really try to understand what's going on. But I don't feel I understand them well enough to answer those questions you were asking about whether the workspace is surprising or not.
You said you went from 0 to 40. 0 to 40 to what? To credence that they're conscious, or to just being affected by
0
it?
to 6. Well, I was being modest with 0. I'm trying to go 0 to 60 or more than 60 miles an hour. What I mean by that is I knew very little about them 3 months ago, and now I'm trying to learn as much as I can very quickly. I don't think there's any good reason to believe that they're conscious systems. I think both with respect to the kind of what they're doing, the processing side, what kind of activities they're engaged in, and also with respect to the hardware. I think there's probably a hardware constraint of some sort for consciousness. So I have a very low degree of belief that any present-day computer system is conscious.
What are your views on the simulation hypothesis?
By that, I take it you mean the hypothesis that we right now are in a computer simulation that someone has created either to study us or for recreational reasons or for some hard to understand reason, but we are artifacts, we're programmed artifacts within a computer system of some sort. Yeah, I don't take the hypothesis seriously at all. I'm surprised when people give it the relatively high degrees of belief that people sometimes give it. I just think there's no reason to believe it for a few reasons. I mean, in some ways, we could go through 2 or 3 or 3 or 4. The first one, though, is if we are supposed to believe that it's likely that there's a kind of probabilistic argument based on the fact that most minds having experiences of the kind that I seem to be having right now will be artifacts, and only a small fraction will be non-artifactual, will be biological. And that's the version that Bostrom and Chalmers have defended. There's a numerical argument there. It's not just the world might contain some simulated minds, but most of the people having experiences of the sort that I'm having right now will exist within a computer simulation. That's one of the premises that I'm surprised that people are on board with that as much as they are.
Was Chalmers defending that or reiterating that? Because as far as I know, Chalmers isn't a believer in the simulation hypothesis either. He assigns some probability to it.
Well, 25% roughly, he says. In the book Reality Plus, he says he thinks there's something like a 0.25 chance, 25% chance that we're in some kind of simulation. Why is that? Well, because he accepts the outline of the Bostrom argument that a future highly intelligent descendant society of ours will, if it can, make vast numbers of simulated agents and put them in these software-based systems and let them study them or watch them or whatever. He accepts that a future society would do this if it could, and that means that at some point in the future there'll be vast numbers of these simulated minds, enough to outnumber the ordinary biological ones. So the reason to think this is not happening right now is that there are various maybe not, maybe they won't be able to do it. Maybe it's not really possible. maybe they won't be motivated really to do something like that. There's a bunch of discounting factors that take us from highly likely to something like 25% for charmers. And I think that's still much too high a number for lots of reasons. One is, once you take into account how hard it would be to create realistic patterns of experience. And here, actually, this connects back to our discussion of experiential profiles and things like that, although you don't need those ideas to make the point. I mean, experience contains the visual side, and I accept that virtual reality technology is very impressive on the visual side. But ordinary experience includes hot showers, and it includes falling down, and it includes eating too much and feeling like you're too full of food. It includes skateboard crashes and swimming in the surf and all sorts of very bodily sorts of patterns of experience. And the success of virtual reality with visual forms of experience, I think, gives us no reason to think that it would be comparably easy to make hot showers and skateboard crashes and swims in the surf easily simulatable. And the harder it is to create those patterns of experience, the less likely it is that some future society will bother to create countless billions of systems that have those features. If it was just visual, well, yeah, maybe for some reason it wouldn't be that hard perhaps. But if it includes the skateboard crashes and the hot showers and the falling off your skis and stuff like that, yeah, it's a much more challenging technological prospect than I think a lot of people tend to sort of recognize. And again, it's not that a couple of systems in the future couldn't be created that have some of those features, but billions and billions with the richness of an ordinary life being created just for scientific or recreation. I think it's a far more, why on earth would this happen sort of scenario than the proponents tend to acknowledge. So there's one collection of arguments that have the form, this is not a realistic picture of what a descendant civilization will spend its time doing, given how hard it is. A separate and interacting consideration involves whether you can have human-like conscious experiences in a computer system at all, whether you could have minds of the sort that are going through this, what our minds are going through now, existing as software in a computer system. I think we have good reason to believe that, we have good reason to suspect there's a hardware constraint there. And that would be another reason to think that the simulation possibility is less likely. Interacting with the other, because if you had a simulation scenario with biological brains in a kind of matrix type situation where the cells are there, the chemicals are there, they're just being fed unusual inputs, that's one thing. Much more expensive and hard to build, I take it, than a purely software-based thing where you just have a bunch of computers running on huge solar arrays with very sophisticated programs running in them. Now, if that second setup can include conscious minds, it's easier to build a experiencing simulation situation than it is if there is a hardware constraint and the only entities that have human-like consciousness are biological. Then it's much more difficult.
What do you mean by hardware constraint?
Right. I think that there's, once again, no one should be too confident about this. But I think there's some good reason to think that the features of our brains that make consciousness possible in us, and the features in octopus brains and bird brains and so on that make consciousness possible in there, don't just involve the point-to-point networked connectome represented sorts of activities where one cell fires and makes another cell fire, makes another cell fire. I accept that if all you needed to have the functionally important parts of a human brain was a network with the right connectivity and the right patterns of interaction, then a computer is not a bad place to have that happen. But if you think that more that's going on in our heads matters to consciousness than the network interactions, then you would have to put that stuff in the computer and not just represent it, but sort of have it physically present. And that, I think, is potentially much harder to do. Right. So what things in our heads might be important? The candidate that I am most interested in, the one that I'm exploring because it has interesting empirical work surrounding it at the moment, involves the interaction between the point-to-point network-based stuff that happens in a brain and large-scale oscillatory dynamics, the sorts of things picked up in an EEG machine and similar technologies, where as well as cells making cells fire, you have sub-threshold. Like this is not just the aggregate features of action potentials of cells firing. This is a sub-threshold, sub-action potential phenomenon. You have oscillations on a large scale in the brain that are electrical oscillations that do what? That's the big question. Plenty of people have thought that do nothing, that are just like the hum of the machine. When you get an EEG reading from someone as they're doing stuff, you're just listening into idle byproducts of the processing. Some people have thought that. I think that's becoming less likely now. And it's reasonably likely, at least, that there is a kind of unifying or organizing role that these oscillatory patterns have within our brains, which is over and above the network, point to point, this cell fires, makes that cell fire side of things. It interacts with that. I mean, the two sides of brain activity are in tight connection, the large scale rhythmic oscillations and the point to point stuff. But they're not the same thing, and one is not reducible to the other. For example, just, if one's wondering why these things might matter at all, there are distinctive oscillatory patterns that are seen when a person is asleep versus awake, or when a person is under anesthesia. If a person is attending closely to something with their eyes open, like sort of focused visual attention versus a sort of non-attentive, non-focused, perhaps eyes closed situation, but still awake. All of these things have rhythmic signatures in the electrical activity of the brain, and they might be byproducts, but if they're byproducts, they are interestingly closely tied to these consciousness-related states, sleep versus wake, attentive versus not attentive, anesthesia, and so on. And one of the things that I have to say really amazed me about this whole area, one of the things that made me want to learn more about it, is the fact that these associations between oscillatory patterns and consciousness-related states like sleep versus wake and attentive, inattentive, and so on, it's not just a human thing. It's all over the animal kingdom. There's some work that I'm especially interested in that's done up in Queensland, northern part of Australia, in Bruno van Swinderen's lab on flies, fruit flies, Drosophila, these tiny flies, nervous system, couple of 100,000 neurons, and they have sleep, which is interesting. They have active sleep. They also have attention. I mean, you can study which of several objects in a fly's visual field is it paying attention to. Mm-hmm. And there seems to be an association between attentiveness and a particular large-scale rhythmic pattern in those flies' brains. Not exactly the same as there is in our brain, but surprisingly similar. It's a beta rhythm, 20 cycles a second, that seems to be associated with attentiveness in a fly's brain. And beta rhythms don't have a totally unrelated role in our brain. And if we once again think about the tree, the evolutionary tree, the common ancestor of you and an octopus is the same animal as the common ancestor of you and a fly. So the fly and the octopus have a common ancestor here. And then there's an earlier common ancestor that is the ancestor also of vertebrates like us. So if a fly is using these oscillatory patterns to sort of help it manage attention, and we are doing a not dissimilar thing, I find that, I must say, I find that a kind of astounding fact about the history of animal life that probably, again, does involve a kind of convergent or parallel evolutionary process where a similar resource is being put to work in a way that's somewhat similar across these two very different evolutionary lines. And as Van Swinderen and his collaborators say in one of their papers, this doesn't look like an epiphenomenon. It doesn't look like it's just an accident. If there's a similarity between us and them in the relationship between attention and an oscillatory pattern, it'd be pretty weird if that was an accident both times rather than being functional both times. And, you wouldn't want to overdo that argument, but I think that's not a bad argument. And that suggests, again, it's one of the bits of evidence that suggests that these non-networked, these more holistic patterns of electrical activity in brains really matter to consciousness-related phenomena.
Okay, let me see if I understand this. So right now I have a desktop computer beside me, and it's making a variety of noises because of its fan, and it's also exporting some heat. And so we see that as an unwanted byproduct that's actually unnecessary to the computation. In fact, the heat you can overheat a computer and destroy it. So it's not even a wanted byproduct. And what we think is most important is the information processing and somehow the causal pattern of that information processing, much like the kids throwing hot potato, a more complicated version of many kids throwing many different hot potatoes. And in the hot potato scenario, you hear some sounds and you hear kids laughing and blah, blah, blah. And that doesn't make a difference to the information processing. So something that's going on in our brains are these waves, which are ordinarily thought of as this noise that's somehow downstream from the important conscious activity. You're saying, no, maybe it's upstream. Maybe consciousness depends on these rhythms.
Right. It's not that it comes from the rhythms or it is the rhythmic pattern or anything like that. Rather, it's the idea that brain activity, the thing that's going on in here that makes us conscious, has these two sides to it. There's the network point to point, this cell fires, that cell fires side. And there's this other side, the more diffuse, holistic, large-scale dynamic patterns, where each affects the other. It does seem likely, for example, there's now quite a lot of work on the idea that the oscillatory patterns help synchronize other kinds of activity within the cell, within the brain. So it enables events to happen in a way that's closely synchronized in time, in a way that would be quite difficult if the oscillatory patterns weren't doing their thing. Now that's a good example of something. Suppose that's true, and suppose that synchrony is important to consciousness arising in a brain. That would not be a situation where the rhythms make us conscious or the rhythms are consciousness, but it would be a situation where if you take away the rhythms, the machine won't do what it has to do because the synchrony really matters. And in a brain, synchrony is difficult to achieve, perhaps, and you need something like this diffuse oscillatory pattern to enable synchrony to be brought about. So that's a kind of model case for the kind of explanation that I'm offering. And then the last step is the idea that computer systems don't have properties like this. They have the network stuff in a sense. I mean, the question of whether computers Whether neural networks in a computer really are networks is an interesting question, but let's just assume they are, which I think is reasonable. They don't have the other side. There's the other side of the brain, and the computer doesn't have that.
So you're not saying that there's more to consciousness than just the functional account. You're saying that computers are so sterile and abstract of an environment, and there's something that we ordinarily think of as the messy processes of biology that you can abstract away and get consciousness. You're saying, no. Maybe much of that noise, that messiness, is integral to consciousness.
And what we thought of as noise, what we thought of as noise is not just noise. It's integral to consciousness.
If suppose we want to build a conscious computer, then we would want to engineer some of that messiness in a coherent fashion. And at that point, you may as well make a biological brain. Would you go so far as to say that the most optimal conscious mind is a biological brain?
Let's go through each of those steps. I think are worth a little bit of time. The first thing, something about the way you expressed it, I want to very much endorse, which is the idea that it's not just that these rhythms might be important. They are just perhaps an aspect of a more general role for biological details that we didn't realize were important and actually are important. So some people think that the role of subtle neuromodulator chemicals, which don't operate in the same targeted way that neurotransmitters do, but they have a lot of effect on what the brain does.
Mm-hmm.
Some people think they're very important. Fine, yes. It's not that I'm saying I think the oscillations are important and this other stuff is not. I think there's probably a whole collection of things that, to use your language, look like it was just part of the messiness, might really matter. So that's the first thing I want to say. Suppose we believe that, and we still want to make an artificial mind, then it's not that I think that would be impossible without using proteins and blood and nucleic acids and the other biological raw materials. It's not that I think we could never have a different physical material that might do the same job, but it will be different from a regular computer, that's for sure. It wouldn't just be you've got this big memory and these processing units rewriting values of variables in memory in this astoundingly complex way. It would have to have some of the kind of physical cohesiveness that a brain has. And whether you can build the duality that I suspect is important in a brain in a totally different physical system with different raw materials, that's very much an open question. I have no intelligent speculations about computer hardware possibilities that I could offer there. I think of it as a real unknown.
Okay. You said it was an open question. Where I was going to go is I was going to say, okay, so is what you're saying then to mind upload, which we ordinarily think of as you transfer your consciousness into some software package and you put it into a server somewhere. Mind uploading is possible under your view, except that probably the most efficient way to mind upload would be to just clone your brain, have another actual biological brain in some lab somewhere. And then it would inherit all the fragility of which we don't want, which is one of the reasons we like the server, because you can easily replicate and put it anywhere across the solar system, if you like, or galaxy.
Yeah, once it's biological, I mean, to return to a term that you used a few minutes ago, biological systems really are noisy. There's a sort of noise inherent to how nervous systems work, and it won't really be a copy. I mean, you might think this thing you've built is a copy momentarily of the pattern of activity that's going on in you right now, but once you've done it'll go its own way. It's its own thing. It'll have its own noise-driven pathways of divergence that will lead it to a different place. So there's no kind of uploading scenario of the sort that's interesting in fiction that I think of as a sort of natural, realistic possibility. Neither biological nor non-biological. But again, who knows? Maybe there could be a hardware that was not like ordinary computer hardware and is not like a living brain either, but that has the sort of combination of properties that matter in nervous systems to enable consciousness that could at least be an artificial consciousness. And then you might think about duplications and uploadings and things like that in relation to that system.
Suppose we swap one of your neurons, one at a time, with a silicone chip or something that's made out of silica. And they perform exactly as the original did, so they have functional equivalence.
Right. That's where I get off the boat. But go on. Yeah.
Okay, just stay on the boat for a little bit, please.
Yeah.
Okay, now I imagine that your behavior reports don't change. So like you would keep insisting, I see the same colors, I see the same clouds, blah, 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 blah. Then if you were on the boat, you got off, but I'm speaking now to an imaginary Peter. Does that Peter's experience fade out, or is introspection then lying to you at that point? Or it's like, Curt, I've got off the boat. Sorry.
Yeah, well, let's talk about why one should get off the boat. I got off the boat at the exact moment when you said exact. So you said we can take one neuron and replace it with something that does exactly the same thing, and that's the exact moment of my boat departure is the moment when you say exact, because I don't think that a artificial silicon-based object like that could do exactly the same thing. And this relates to that discussion of oscillatory patterns in nervous systems, among other things that we talked about earlier. I mean, what's that neuron doing? Well, it's got all these membranes. And there are ion flows going back and forth across that membrane all the time, not necessarily causing an action potential. There's this kind of, it's being pushed slightly away from its normal, somewhat negative state inside the cells, being slightly depolarized or slightly hyperpolarized, slightly more negative, slightly less negative inside the cell by these flows of ions, especially, but not only positive ions going in and out.
Uh-huh.
And that's contributing to the way that the cell enters this ensemble of processes that are continually going on. When it's a bit depolarized, it's a bit more likely to fire when it gets certain stimuli, and so on. It's also, the cell is contributing to the ebbs and flows of neuromodulators and other chemicals, small molecules like nitric oxide that are affecting how the brain works. It's doing all that stuff. Now, if you put something in there that doesn't have membranes and doesn't have ion flows across the membranes and doesn't have the same chemical sensitivities as the neuron, then it might do some similar things to what the neuron did. It might have a similar set of propensities in relation to the network, point to point, this thing fires, then that thing fires properties. But it won't be exactly the same. And if you put a lot of those, if you put just one artificial neuron in there that's not exactly the same, I imagine that will have no effect. Well, sorry, not no effect. It will have a very, very small effect only on anything. But once you put 1,000, 100,000, 1 million, 100 million, it's going to make a difference. And you'll wind up with a different object, a different kind of thing. It will think differently. It'll talk differently. It will be the idea of behavioral indistinguishability as you sort of do a large-scale replacement of the biological with artificial. I think that's kind of a fantasy. I don't think there's any reason to believe that that's viable. So, if you were doing it to me, people would start to notice. I don't know when they would start to notice. I would start to feel pretty weird, I assume, because if it's true that these oscillatory patterns are helping to synchronize neural activity, then as you degrade that side of my brain, I might become less cohesive in my experience. All sorts of things are likely. Something will happen. Right. So that's why I got off the boat when you said that what was put in there was something that would do exactly the same thing.
This is interesting. This happens over and over in biology. That's something that we thought of as somehow ancillary. It's an incidental collateral effect. It's actually integral. So junk DNA, for instance, and even the microbiome, I think people
microbiomes are good. That's a really good example because there's no doubt now that it's very important.
It's also one of the reasons why I don't like when someone says that the function of so-and-so, especially if it's biological, is this. So for instance, people will say, the heart isn't the heart. The heart is just whatever pumps blood. And so a pacemaker is an equally good heart. But a heart is much more than that. It has fibroblast cells. It has some immune properties and extracellular matrix and macrophages and so forth. So it's not clear to me that that's so discardable. Now, of course, you can just watch someone's lifespan and then see that it's equivalent. Maybe, maybe not. I don't know. I don't know if that's the true test.
That's interesting. Yeah, I don't know much about hearts. And maybe it is true that almost everything in a body has what we think of as its sort of primary role or roles, and a whole bunch of ancillary, but not really ancillary, a whole bunch of additional things it does.
Do you just outline something like, I don't know what it's called, the rhythmic theory of consciousness or the rhythmic importance of consciousness? I don't know, but whatever. Well, what's the most speculative theory of consciousness that you've entertained? Perhaps you've gotten off the boat now, but it's one you've got on the boat at some point. And why did you get on it and why did you abandon it? Or maybe you're still writing.
I've never really had, I've not had a theory of my own until the beginnings of these ideas that we're talking about now. And when people like David Chalmers and Thomas Nagel began kind of sort of just pressing again, saying, no, this is really hard. There's a problem here. Don't just think that a materialist treatment of the mind is straightforwardly, coming into view with the development of ordinary science. It's much harder than that. I mostly agree with that pressure, the renewed pressure that they brought. And I don't agree with either dualist or panpsychist responses to it. I think those views are not supported. But there's a need for new theory. There's a kind of, the term that Joe Levine used years ago, the idea of an explanatory gap between the physical and the experiential. I think that's a really good way of looking at the situation. There is an explanatory gap. And insofar as I have a view of consciousness, it's the idea that what makes it possible for consciousness to arise in a physical system is some special properties of nervous system activity, the combination of the networked computational interactions and these organizing, unifying, large-scale dynamics, large-scale electrical dynamics as well. You need them both. That's a sort of a theory. And in one paper, I coined the term neural dynamics of subjectivity as a name for this approach. So it emphasizes the importance of the neural, of the dynamic, and of the idea. We talked about selfhood back at the beginning of this conversation. I think subjectivity has a lot to do with selfhood, with point of view, with perspective. So it's all those things together. Now, if you right, so that I haven't really had a theory of my own. I still don't really, but I have a direction in which I think a theory might be developed, and that's the direction that we've just been talking about. I haven't abandoned something radical earlier or anything like that.
Have you seen Remarkably Bright Creatures?
No, I've read some of the book and I've been enjoying it, but I haven't seen the film yet. People love it, it seems.
Yeah, well, like I'm a film buff. I used to be a filmmaker, and they don't make many movies that almost every movie nowadays has to have some cynical message in it. And it's so rare to have a movie that's just a joy to watch and you smile because it's earnest.
Okay, don't tell me what happens because I
won't.
I haven't finished the book or
I recommend it to the audience. I recommend it.
Yeah.
So when I was first interested in cephalopods, before I even knew the term cephalopod, I was interested in cuttlefish. Every documentary that I saw talked about how remarkable cuttlefish are. and not about octopi or octopuses. So tell me about the distinction between those two.
Okay, yeah. Cuttlefish are just wonderful. And they are actually the animal that got me started down this path, because I encountered them in the water before I encountered octopuses. And I began looking for octopuses partly because I'd become obsessed with the Australian giant cuttlefish, which is the biggest species in the world. They're just amazing, amazing animals. And right, let's talk about them. So that there's the three kinds of cephalopods that are the complex ones: octopuses, cuttlefish, and squid. And cuttlefish and squid are more closely related than either of them are to octopuses. And the divergence in evolutionary terms, I've forgotten the exact date, but it's pretty deep. It's a deep divergence. It's way back. It's well over 100 million years. And cuttlefish, right, they're certainly very sophisticated behaviorally. And some of the most interesting experiments with respect to learning and behavior have been, in recent years, have been done on cuttlefish rather than octopuses. Alexandra Schnell, who's an Australian researcher, has done some remarkable work on cuttlefish. For example, in one of her papers, cuttlefish more or less pass a version of the marshmallow test. I'm sure you and your viewers are familiar with that. You know, you offer the kid either one marshmallow now, or if they can hold off and exert some self-control, they get 5 later or something like that. And it's, for small kids, self-control is very difficult. And for lots of non-human animals, self-control is very difficult. And cuttlefish didn't do too badly. They did better than a lot of animals and better than I would have expected. They were able to forego the lower quality food, because if they waited, then they would get the higher quality food. They passed a marshmallow test. Now that's something I think no one really expected. That was a very, very elegant piece of work. So there's less known about them. They have large brains of around the same size as octopuses, similar scale, not quite as dramatic in their behaviors, with respect to their inquisitive and attentive and exploratory styles, but they do have some of that, especially the Australian giant cuttlefish. They can be quite curious about humans as well.
Have you studied giant squid?
No, it's pretty hard to study giant squid.
I thought so. That's why I was laughing during it. But they freak me out. So I don't have many fears, but one of my fears is the ocean, the deep ocean. And even seeing photos of sperm whales, I think it's sperm whales that just sleep standing up.
Yeah, they're amazing.
There's something ominous about that. And then hearing that they encounter fights with giant squids and they eat them. And there's something that just freaks me out about that. There's a lady, I think her name is Eddie Witter, and I'll place a link on screen because I may be mispronouncing it. She invented something called e-jelly. Have you heard of this?
No.
So this is 10 years ago. Or 13 years ago. I want to bring her on the show. It turns out when you go extremely deep in the water, you don't find any giant squid. And it's odd because if you do a calculation to how many giant squid should there be given how much are inside of sperm whale stomachs, like their teeth and so forth, the deep ocean should be teeming with much more than we find, which is 0. We find 0. So she thought, well, maybe it's because we have our lights on. It sounds so obvious. Maybe it's because when we're diving, it's so dark down there, you turn your lights on, they just run away. So she created something called e-jelly, which shines like a certain type of jellyfish. And within 30 seconds of turning that on, or within 1 minute, a giant squid came. And it was the first ever live captured deep ocean giant squid. And that freaks me out. But I'm interested in it.
And you're not interested in a kind of affectionate, positive way. You find them not a good...
I don't want to play with them. No,
a good thing.
But I think it's terribly interesting. Maybe terribly is the key word there.
Well, if you come to Australia, there's a place where you can hang out with giant cuttlefish that they look a bit like giant squid in some respects, and they're quite friendly. You might find
they earn the cuddle in the cuttlefish.
Well, I'm not saying that, but they have a pleasant a pleasant style of activity some of the time.
So what are you working on now? What's exciting you?
Well, the things that we talked about a while back, I mean, the question, what is a mind, that's a good question. That's a central question, even though I think that the way to approach it is going to have some of this indirectness where we understand selfhood, we understand certain kinds of information processing, we put them together and we find we understand the mind, even though we thought we were talking about slightly different things. That's the analogy with life again that I find helpful. You sort of approach the phenomenon from the side by looking at these components or these aspects of it, and explanation just emerges from your understanding of these aspects of the whole. That's the approach I'm trying to develop in a bit more detail, because I think this question of how to have a truly gradualist attitude to the presence of mind, where it's not a yes or no, it's a more graded phenomenon, that's really important. And the pressure that you put on it, when we talked about that, that's the pressure point for views like that. So trying to make sense of that set of questions and themes, fairly abstract. So I'm working on that. I'm looking at some very exciting recent work on pain and pain-like experience in various animals, especially insects. There's been a flurry of papers in the last couple of years that make the case for insect pain much stronger than it was a few years ago. I mean, that's just how the work's turned out. That's very exciting. Those are the main things.
Well, that's terrifying and not exciting to me, because I'm sure you can imagine.
Well, because it changes the ethical landscape, yeah. I think we're going to be thinking about that.
Professor, thank you for staying up so late, and I appreciate your invitation to go to Australia and play with the cuttlefish.
Yeah, I'll show you some friendly ones. That would be fun. I listened to some of I wouldn't usually give such long answers, but I listened to some of your other shows, and that seems like you welcome that, right? I wanted to do things as deeply as I could.
Thank you. Hi there, Curt here. If you'd like more content from Theories of Everything and the very best listening experience, then be sure to check out my Substack at Jaimungal.org. Some of the top perks are that every week you get brand new episodes ahead of time. You also get bonus written content exclusively for our members. That's CurtJaimungal.org. You can also just search my name and the word Substack on Google. Since I started that Substack, it somehow already became number 2 in the science category. Now, Substack, for those who are unfamiliar, is like a newsletter, one that's beautifully formatted. There's zero spam. This is the best place to follow the content of this channel that isn't anywhere else. It's not on YouTube. It's not on Patreon. It's exclusive to the Substack. It's free. There are ways for you to support me on Substack if you want, and you'll get special bonuses if you do. Several people ask me, like, hey, Curt, you've spoken to so many people in the field of theoretical physics, of philosophy, of consciousness. What are your thoughts, man? Well, while I remain impartial in interviews, this Substack is a way to peer into my present deliberations on these topics. And it's the perfect way to support me directly. CurtJaimungal.org, or search Curt Jaimungal Substack on Google. Oh, and I've received several messages, emails, and comments from professors and researchers saying that they recommend Theories of Everything to their students. That's fantastic. If you're a professor or a lecturer or what have you, and there's a particular standout episode that students can benefit from, or your friends, please do share. And of course, a huge thank you to our advertising sponsor, The Economist. Visit economist.com/toe, TOE, to get a massive discount on their annual subscription. I subscribe to The Economist, and you'll love it as well. Toe is actually the only podcast that they currently partner with. So it's a huge honor for me. And for you, you're getting an exclusive discount. That's economist.com/toe, T-O-E. And finally, you should know this podcast is on iTunes, it's on Spotify, it's on all the audio platforms. All you have to do is type in Theories of Everything and you'll find it. I know my last name is complicated, so maybe you don't want to type in Jaimungal, but you can type in Theories of Everything and you'll find it. Personally, I gain from rewatching lectures and podcasts. I also read in the comment that Toe listeners also gain from replaying. So how about instead you re-listen on one of those platforms like iTunes, Spotify, Google Podcasts, whatever podcast catcher you use. I'm there with you. Thank you for listening.